You've probably shaken 1,000 hands in your life, right? It's super simple, a universal sign of trust, of agreement. But what if I told you that this exact same idea is one of the secrets behind why your computer, your phone, heck, every single smart device you own is just so incredibly fast?
Yeah, I know. It sounds like a weird question, doesn't it? A human gesture, a silicon chip. But believe it or not, the connection between them is this totally brilliant piece of engineering that, and I'm not exaggerating, completely revolutionized computing. All right, let's get into it.
Okay, so first things first. Let's just break down the human handshake itself. I mean, when two people shake hands, they're not just, touching palms. It's so much more than that. They're communicating. They're basically saying, hey, I'm ready. Yep, I agree. We're on the same page. Let's do this. It's really just a protocol, a way to kick off an interaction.
So, let's take that same idea and bring it into the digital world. Deep inside your computer, you've got all these different parts that need to talk to each other, right? The processor needs to chat with the memory needs to ping the graphics card. And they do it with, you guessed it, a digital handshake. It's just an automated signal where one part says, hey, I'm ready to send you some data, and the other part replies, cool, I'm ready to receive it. It's all about that perfect split-second coordination. Now, to really get why this coordination is such a game changer, we kind of have to travel back in time a bit and look at how the first computer processors worked. Their main job is actually pretty simple, just execute instructions. But the way they first went about it, well, it had this massive bottleneck built right in.
So the early processors, they worked sequentially. Just picture a really strict to-do list. The processor would grab the first item, let's call it instruction A, and it had to do the whole thing, start it, process it, and completely 100% finish it before it was even allowed to glance at instruction B. One thing at a time, from start to absolute finish. Here's an easy way to think about it. Imagine a single worker trying to build a whole car all by themselves. They have to fetch the chassis, then install the engine, then put on all the wheels, then paint the body. The entire car has to be totally done, keys in the ignition, before they can even start thinking about the next one. Yeah, you can see how that factory is not going to be breaking any production records.
So, naturally, engineers looked around and borrowed a truly revolutionary idea for manufacturing, the assembly line. And in the world of computing, this is called pipelining. And trust me, it completely changed the game. The big idea? Breaking one huge job into a bunch of smaller, manageable stages.
So instead of one person building the whole car, we now have these specialized stations, right? Well, the exact same thing applies to a computer instruction. It gets broken down. You've got one stage that fetches the instruction from memory. The next stage decodes it to figure out what it's supposed to do. The third stage executes it, does the actual math. And the final stage writes back or saves the result. 4 clear, distinct steps.
Okay, and this is the magic. This is the absolute core breakthrough of the whole idea. As soon as that first instruction moves from the fetch stage to the decode stage, the fetch stage is now totally free. So what does it do? It immediately grabs the next instruction. So at any given moment, you have multiple instructions all being worked on at the same time, just at different stages. It's literally like having multiple cars moving down the assembly line at once.
So let's be super clear about the difference here. We went from a world of sequential processing, one instruction completes at a time, to a world of pipelined processing, where multiple instructions are in progress at once. We didn't make the process of building a single car any faster. But man, are we getting a lot more cars off that assembly line every single hour? All right, so now we have this amazing, super fast assembly line, right? It's moving at basically the speed of electricity. But with all this stuff happening at once, how do you stop it from turning into total chaos? How do you make sure one stage doesn't just flood the next one with work it's not ready for? Well, this is where our handshake concept makes its grand return.
Seriously, think about it for a second. If the decode stage isn't ready, but the fetch stage just plows ahead and sends the data anyway, poof, everything crashes. The whole system goes down. It's this incredibly high-stakes, super high-speed coordination problem. So, how do they solve it?
That's the answer. This whole incredible assembly line, this entire pipeline, it's all managed by millions and millions of invisible, nanosecond-fast handshakes happening every single second.
And here's how it actually works. The fetch stage basically taps the decode stage on the shoulder and asks, hey, you ready for this next instruction? And only when the decode stage signals back, yep, I'm done, send it over, does the handoff happen.
This little handshake protocol happens between every single stage for every single instruction. It's what prevents those data collisions and keeps that whole assembly line moving buttery smooth.
Okay, so this is all cool theory, but what's the payoff? What does this actually mean in the real world for you? Well, the benefit of this elegant little solution is, honestly, it's staggering, and it's humming away inside every single device you use.
Let's put a hard number on it. A basic 4-stage pipeline, just like the one we've been talking about, can result in a performance increase of more than 3 times. And get this, that's just the starting point.
Yeah, that 3 times number? That's from a basic pipeline. The processor that's sitting in your phone or your laptop right now, it doesn't have just 4 stages. It might have 10, 15, maybe even more than 20 stages. Each one of those is another station on the assembly line, letting even more work happen in parallel, all kept in perfect sync by those little digital handshakes.
You know, this quote really hits the nail on the head. Pipelining doesn't actually make any single task faster. In fact, it might even take a tiny bit longer for one instruction to get through all those stages. But, and this is the key, that doesn't matter. What matters is the throughput. How many tasks you get done in the same amount of time. And pipelining just shoots that number through the roof.
So, yeah, the next time you're just amazed by how fast your phone is, just remember the handshake. A simple, totally human idea of agreement and coordination just scaled up to lightning speed, working away invisibly to power our entire digital world. Kind of makes you wonder, right? What other beautiful human ideas are hiding inside the technology we use every single day?